Hi everybody, welcome to another video in statistics. We continue chapter 3, measure of central tendency, which is the mean, the mode, and the median, and measure of dispersion, that's the standard deviation variance. But this time we have the group data. So group data is where we have an observation, but that occur more than once. Right. For the population mean and the standard, the sample mean, just what is the observation, how many times that occur, divided by the total number of the frequency. Right. So population mean is the mu, and the sample mean is the x bar. For the group data, for x observation xi with the frequency fi. So xi is the midpoint of the observation for that observation, and fi is the corresponding frequency. Right, here is an example. The National Survey of Student Engagement is a survey that asks first year students how much time they spend preparing for class each week. So those are the time. Okay, so right now in the 0, so we have those are the time. Will be 1 to 5. I don't write 1:30 yet. 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21, 25, 26, 30, and 31, 35. Right. So those are the classes. Now next we need to find the class midpoint. Sorry, don't have the bar on the top of it, just the xi. Right, so for each class, we use the class midpoint to represent the class. Now, remember when on the previous chapter, when we find the class midpoint, we take the average of the consecutive lower class limit. We still do that here, but with an assumption is, for this survey, let's say if the student respond exactly with 5.99, in that case, if 5.99 is the case, will be classified into here, into that class. So we'll always round it down. If it's 5.99, it belongs to this class. If it's 6.01, it belong to this class. So with that assumption, then yes, we can take the average of the mean, the average of the consecutive lower class limit, 6 plus 1 divided by 2, so that's 3.5. However, if we're talking about the number and we're rounding, like for example, if it is 5.4, it belongs to this class, and if it is 5.6, it belongs to the next class. If that is the case, we just take the average of this. We don't take the average of the consecutive class limit. Now with this assumption is that whatever it is, we round it down to the integers, the lowest integers, the integer that is the greatest integers smaller than that, for example. So with that in mind, then we can take for the mean of the consecutive lower class limit. So 6 plus 1 is 7 divided by 2, 3.5. Right. Once again, the assumption is that whatever the decimal is, we take the greatest integers that is close to it. So for example, if it is 3.99, we round that to 4. We round that to 3. Always round down in this case. Right. 6. to 10. Okay. Once we have that, then we're just going to add 5, 6 and 11. That, I'm sorry, 1, 6. Then 6 and 11, that is 17 divided by 2 is 8.5. So pretty much we just add 5 to it. Add 5 here will be 13.5, 18.5, 23.5, and then 23.5, 28.5, and the next one will be 40, I'm sorry, 36 to 40, so 31 and 36. That gives us 33.5. Right, we don't really need that. But we need the lowest class limit for the next one. Right, so those are the class midpoint. Right, we assume that we round down everything. Right, next, the frequency. How many times do we have for each one? Now that's 130, 250, 230, 180, 100, 60, and 50. Right. Now that pretty much this number occurred 130 times, and then this number occurred 250 times. So what we do next is just multiply those. Right, 3.5 times 130. Right, there's a better way to do this is using the list. 3.5, 8.5, 13.5, 18.5, 23.5, 28.5, 33.5. Right. Next, the frequency 130, 250, 230, 180, 100, 60, and 50. Right. Right, and then we go to L3. Highlight L3. What we do is second L1 times second L2. So we multiply this and that, and that's what we have. Just copy those numbers for 55, 21, 25, 3105. 33, 30, 23, 50, 17, 10, 16, 75. Now we're just going to add all this up. Right. Of course, we can add all of that by hand, but there's another option to do that. Is that go to calculate, second stat, go to math, and option number 5, and we say we're going to add everything on list number 3. Right? Add everything on list 3. Once again, second stat, go to math, option number 5, that's summation, and go to list 3. If we add all of them up, now the sum of all of this is 14,750, and then we add all of the frequency, that is list 2, and we add everything in list 2. That's 1,000. And we divide this. The mean is the sum of all the xi, fi, which is that number, divided by the sum of all the frequency. So 14,750 divided by 1,000. So that gives us 14.75. And this should be in hours. Right, so put everything in list 1, list 2, and multiply, add all of them up, divide by the sum of frequency. Even better than that, there's what we call the two variable statistic. So hit stat, calculate, this time two variable statistic. Calculate still one variable statistic. List 1 and list 2 is the frequency. Alright, sorry, should be still one variable statistic. Now calculate. Alright, so the mean 14.75. Yeah, so that's what we have. Right, simple enough. Right, let me go with the StatCrunch and see what we have. Again, open StatCrunch in learning materials. StatCrunch website. Open StatCrunch. Right, I'll enter what we have earlier. Sorry. 3.5, 13.5, 18.5, 23.5, 28.5, 33.5. Right, the frequency 130, 250, 230, 180, 100, 60, 50. Alright, now stat, summary statistic, columns. See if we have 2 columns. Calculate the mean. Right, that doesn't work. Let's do that again. Statistic, summary statistic, and of course we have the group data this time, right? Choose that. Right. Variable it did not show, for some reason it did not show the option, but we choose bin in variable 1 count, which is the frequency, count 2, and then choose the mean. Now compute. Alright, 14.7. Alright, once again, stat, summary statistic, group data, and the bin we select variable 1 and variable 2. It has a pop-up, so it did not show, but we choose variable 1, variable 2, and then calculate the mean. Of course, later on we can choose the standard deviation and other things, but that's what we have for the StatCrunch. Right. Next, what we have is the weighted mean, kind of like what we have here, which is the mean for the group data. The weighted mean, the variable is found by multiplied each values with the corresponding weight, and then divide by the total weight. So exactly like what we have here. Instead of the frequency, we have the weight, and the weighted mean is denoted by that. Simple. Let's look at some examples. So again, it is just like the mean for the group data, right? Bob goes to buy the weight nut store to create his own mix. 1 pound of raisins, 2 pounds of chocolate covered peanut, and 1.5 pounds of cashew. The raisin cost that much. What is the cost per pound of the mix? Right. So the question here, this is the cost. So money, right? The unit is dollars. So in that case, whatever it is, that will have to be the first column, because we asked for the cost. The first column is going to be the dollar amount. All right. So we have the raisin 1.25. That's right. The raisins. Next, chocolate covered peanuts 3.25. And cashews. That's too long, but not gonna write that. Cashews 5.4 dollars per pound. Now the weight. The weight: 1 pound of raisins, 2 pounds of chocolate covered peanuts, and 1.5 pounds of cashews. Right. So list 1, list 2, one variable statistic, list 1, list 2. Pretty much it. Right. If we're going to do this by hand, the cost per pound is going to be the weighted mean. So we're going to add 1.25 times 1. Yeah. Actually, I'm just multiply this. 1.25 times 1. 3.25 times 2. And 5.4 times 5, 1.5. Right. And we just add all of that and add on the weight and then divide backward. $15.81, 85, and then on the total weight 4.5, and then divide, you have the weight. Or we just write it down. The total weight. Right, we did calculate that is 15.85 and 4.5. $3.52, and the unit here will be dollars per pounds. Dollar per pound. So just that the unit of the weighted mean and the L1, the first list must be the same. So that's why when we look at the problem, we have to determine which one is L1, which one is L2. When we have that, just go with the list. Right, stat. Right, how do we clear everything? Once again, highlight the list, never hit delete, just hit clear. Right, then I enter 1.25, 3.25, and 5.4. The weight 1, 2, 1.5. Right, second mode, back to home screen, and then we will calculate the one variable statistic. List 1 the values, list 2 the frequency, and then calculate 3.522, right? Now let me just want to switch to the other calculator real quick. I have to do the same thing. And the same thing with the StatCrunch. And then again, stat one variable statistic. We just have to enter list 1 comma list 2. Yeah, the syntax different with this kind of calculator, but essentially calculate the same thing. Right. Next, according to syllabus, actually this is not our syllabus, it's different. Let's say if we have that, calculate the grade. Okay, this is the grade. All right. 90 on homework. And the homework, the weight is 90%. I'm sorry, homework 15%. Or 0.15. 65 on the midterm. And the 4 tests. Right. The 4 tests is 80, 80, 70, 75. Right. Let's just calculate the average test. $80, 80, 70, 75 divided by 4. $76.25. Right, and that is for the weight of the test, the total 35%. The midterm 65, and that 25%. And the final 25%, and we have 60. Right, so that again just multiply and then divide by the total weight. The total weight here, since this is percentage, the total should be 100% or 1. Now we find the product of these two. Right. Oops, I entered the wrong thing. Right. Yeah, we can delete those entry but never delete the list. Delete the numbers okay, but never delete any list. 76.25, right? $65, 60, 0.15, 0.35, 0.25, 0.25. Right, of course here we can multiply once again, highlight L3, say list 1 times list 2, 13.5, 26.6, 88, 16.25, and 15. Right, so we have all that. Now we just need to add everything here. So second stat, go to option math, option number 5. Once again, second stat, go to math, option number 5. The sum. All of that in L3. 71.4375. Of course, and after that we divide by the weight. Divide by 1 still itself. So the average is 71.4375. Of course, you can put that in L1, L2, and then one variable statistic, L1, comma, L2. So pretty much that. Right. Next, we also have the standard deviation or variance for the group data. So the formulas is a little more complicated here. Right. For this problem, I recommend we just use a calculator. Right. So we still have the same problem as before. So I'll just go back to the note from that section and we copy. So we have the time as the midpoint and then the frequency, right? So instead of the time, let's say the midpoint. Three 8.5, 13.5, just the midpoint of those. 18.5, 23.5, 28.5, and 33.5. Sorry. I just copy from page 46. The frequency 130, 250, 230, 180, 100, 60, and 50. Right. And like I said, for this kind of problem, I recommend we just use a calculator. Put the midpoint in list 1 and that list 2, and then do one variable statistic, L1, L2. Clear that. Right, L1, 3.5, 8.5, 13.5, 18.5, 23.5, 28.5, and 33.5. L2, 130, 250, 230, 180, 100, 60, and 50. Right, quick second, just that, calculate one variable statistic, L1, comma, L2. If it is the auto calculator, we choose the values and then the frequency for list 2. Right. If we want, depends on if we want the sample standard deviation or the population standard deviation. So if we use this S is the sample, and sigma is the population standard deviation. Both of them are about 8.1. Right, now how do we use a StatCrunch? Right, luckily we still have the data here. Right, so let's close this. Again, we go to stat, summary statistic, group of bin data. The bins in, we choose variable on the count, which is the frequency, we choose variable 2. So that's what we go with. And then standard deviation, right? So we choose standard deviation. So this is the sample. I will hold control and I also select unadjusted standard deviation. So when it is at hold control and then click to select more than one values and compute. And you have 8.1 standard deviation. This one is the sample unadjusted. So this one is the population. The population standard deviation usually is smaller, always smaller than the sample standard deviation, simply because it's divided by the whole number, not the number minus 1. This one, the smaller the denominator, the bigger the quotient. Right, like I said, when we have the group data and we ask to find the standard deviation, I highly recommend just put on the list, one list to use a calculator, because calculating like this will take a lot of time. Right. So we have the mean, the mode, the median. That is the central tendency, and then the range, the variance, standard deviation. So that is the dispersion. Now, the measure of position. So for that we have the z-score and then a few more things. The z-score represents the distance that the data values is from the mean in terms of the number of standard deviation. We find that by subtract the mean and divide by standard deviation. So the z-score for the population, we use the population mean, population standard deviation. For the sample, we use the sample mean and sample standard deviation. Right, here is an example. The mean height of males 20 years or older is 69.1 inches with standard deviation of 2.8. The mean height for female is 63.7 and the standard deviation 2.7. And use that data relatively to that group, meaning the gender. Kevin Garnett is 83 inches and Candice Parker is 76 inches. So both of them, Kevin Garnett in NBA and Candice Parker in WNBA. So who is taller? Of course, obviously, if we ask them, Kevin Garnett is taller. However, relatively to that group, who is actually taller? So we'll calculate both of them. So the z-score and let's use the population. For both of them. Right, now it's time to write out the summary. Let's do this for KG, Kevin Garnett. X is that his particular values, 83. The mean population, mean 69.1, and standard deviation for the population 2.8. And then put that in the formula. 83 minus 69.1 divided by 2.8. $83 minus 69.1 divided by 2.8, 4.96. Right, now for Candice Parker. The value is 76. The mean is 63.7. And the standard deviation 2.7. So the z-score 76 minus 63.7 divided by 2.7. Whoever got the bigger z-score will be taller relatively. I just switch to the calculator because if you're using this calculator, when you hit alpha y equal to, we can enter the fraction and we enter a number exactly as we see it. And we're 4.55. So relatively, kg is taller. Right, so that we use the z-score. By the way, z-score has no unit, so whatever that number, that is not in inches, obviously. Right, that's another example here. Test score for statistics class had a mean of 79, standard deviation 4.5. Test score for calculus have 69 and the standard deviation of 3.7. A student have 85 on statistics test and 75 on calculus test. Which one is better? Right, so again, divide into two columns. One for statistics and the other one for calculus. For statistics, the mean of 79, standard deviation of 4.5. For calculus, the mean of 69, standard deviation of 3.7. Now suppose a student get 85 on statistics and 75 on calculus. Calculate the z-score and determine which one is better. So z-score, again, the mean, standard deviation, and then that particular case is x. So 85 minus 79, the mean, divided by standard deviation. It's 1.33 something. 33. Right. Same thing, the z-score for the other class. $75 is that particular case minus the mean over standard deviation. 1.62. So this one has a high z-score, so relatively it is better. Right, next we define percentile. The K percentile denote PK. Is a set data in which K% of the observation are less than that. So K percentile, PK, K% of the observation less than or equal to that values. Less than or equal to that values. Alright, here's an example. The graduate record examination GRE test for public is no less than 70 percentile for admission into the interpret this admission requirement. Right, so 70 percentile, what does that mean? So that means if there's 100 person, 70 percentile meaning that 70% of 70% of the record of the score have to be less than that or equal to. Right, and the score is no less than 70%, meaning that if it is 70% or higher will be accepted. So they, again, the 70 percentile by definition meaning whatever the grade is, it including the score that is below that, and that values altogether is 70%. Right. Let's look for something with more particular numbers. Suppose that you score 77 on the test in a class of 10 people with 10 score listed below. What percentage of the score were lower than yours? What was your percentile rank? Right. First thing, we have to put this in the increasing order so we can rank them. Right, so in increasing order, 52, 64, 71, 75, 77, 82, 88, 90, 93, and 98. Right, those are the 10. Now we focus on 77. Okay, the question is, what percentage of score were lower than yours? So therefore, score that is lower than yours, if 1%, 4 out of 10, so that's 40% and less than. So what is the percentile? Well, percentile is whatever the values that is less than or equal to. So we have 5 of them less than or equal to 77. So it has 5 of them out of the total 10. So that gives us 50%. So that is 50th percentile. Right. So again, be mindful with the case when we said the top 1% or the bottom 1% or bottom something percent and those kind of things. Right. Here's another example. The weight in pounds of 12 members of a college gymnastic team are listed below. 5% town rank of who weight 97 pounds. Right, once again, we have to put them in increasing order. 72. 72, 75, 78, 80, 85 and 88, 91, 97, 98, 101, 105, and 120. There are 12 of them, right? Now, find the percentile rank corresponding to 97. So percentile rank is whatever is less than and equal to. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 of them less than or equal to out of 12. At 66.7%. So we're talking about 66.7 percentile. Right? Of course, 99 percentile is very good. I mean, on the top 1%. Right? Let's look at this again. When we have 99 percentile, that's corresponding to the top 1%. Right, now talking about top some percent, and let's look at this. 2 students are competing for remaining spot of a law school. Miguel ranked 51st of the class of 1700, while Dustin ranked 27 of the class of 540. Relatively to their own class, who is better? Right, so we have Miguel and Dustin. Right. Right. Miguel ranked 51st in the class. If it's 51st, meaning there are 50 people above him, grade better than him. In that case, how many people will be below him? Right. Now, if this is 50 people rank higher than him, and the class of 1700. So that means including him and the people ranked behind him, below him, will be 1700 minus that. So we say less than or equal to Miguel. That it's better just write out. So lower or equal to the 1700 minus 50 people rank higher than him, so that's 1650. So 1650 people that equal or less than or equal to Miguel. So the percentage, his percentile, will take this divided by 1700. That gives us the percentile, the percentage, and convert that to percentile easily. Divide 1700. 97.058.06%. So the percentile is 97.06 percentile. Alright, for Dustin, he ranked 27th. That means 26 people better than him. So lower or equal to him. There's the class of 540 minus 27. Sorry, minus 26, because only 26 people rank higher than him. So that's why we have to draw this out, and it's easier to see. Minus 26, 514. Divide by 540. 95.18 per 19. So that's still higher than, I mean, this one is higher. Yeah, so we can use the percentile to compare the two. Right, next we have quartile. Of course, that derived from quarters. Right, so the first quartile, Q1, divide the bottom 25% and the top 75%. So that is the mean or the median of the lower half. And the second quartile is the median. First quartile is Q1, third quartile is Q3. Right, so pretty much we have the lowest and the highest, and then Q1, Q3, and the median Q2. So Q1 is the median of the lower half, Q3 is the median of the upper half. Right, here are the steps. Arrange the data in the ascending order. Determine the mean or the second quartile. After that, divide the data into halves. The observation below or to the left of M and the observation above M. The first quartile is the median of the bottom half, and the third quartile is the median of the top half. Right, a group of BYU Idaho students collect data from the speed of the vehicle traveling construction zone on highway, so that where the posted speed is 25 miles per hour. Alright, so that's what we have. Now find and integrate the quartiles for the speed on the construction zone. So number one, first thing we have to do is random in increasing order. Luckily we already have that. So in increasing order, which we already have. (20, 24, 27, 28, 29, 30, 32, 33, 34, 36, 38. Sorry, I didn't space out perfectly. 20, 24, 27, 28, 29, 30, 32, 33, 34, 36, 38, 39, 40, 40. Right, how many we have here? Okay, we have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 of them. Oh. So if there's 14, and if we want that in half, will be 7 on the top, 7 half, 7 above, and 7 below. Right? So 1, 2, 3, 4, 5, 6, 7. The median will be right here. So that's 7 above it, 7 below it. So since this is an even number, we have to cut this. Take the average of these two will be, that is the median, 32.5, 32 and a half. Now, next we have the upper half. The upper half and the lower half. Just take the median of that. 1, 2, 3, 4, 5, 6, 7. So we have to choose the 1 so that on the left of it and on the right of it will be the same. Right? 1, 2, 3, 1, 2, 3. 3 on the left, 3 on the right. That one at the middle. So this is first quartile. Same thing here. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4. So that is the third quartile. Three on his left and 3 on his right. Right. Interpret the quartiles. Well, so we say a lot of them go past the speed limit. That's what we say. Right, now the interquartile range IQR is the range of the middle 50% observation in the data set. So the interquartile range IQR is the difference of Q3 and Q1. Now, once we have that, we define the outliers. The outliers, when the outliers is the data that is less than the lower fence and greater than the upper fence, then what are the fences? Well, the fences is determined to be the Q1 minus 1.5 IQR and Q3 plus 1.5 IQR. Anything outside of those fences considered to be outliers. So once again, calculate the IQR, and with that we calculate the fences. And once we have the fences, we can determine if there's any outliers. Right, so we said if we use this example, right, for that information, what is IQR? So 38 minus 28, 10, right? So from the first example, let's summarize everything. We have Q1 is 28, Q3 is 38. That's all we need really. The mean is 32.5, we don't need that. First we calculate the interquartile range. Q3 minus Q1, 38 minus 28, which is 10. So interquartile range is 10. Next, we find the fences. The lower fence will be the Q1 minus 1.5 Q IQR the upper fence is Q3 plus 1.5 IQR. Now Q1 is 28 minus 1.5 times 10. 1.5 times 10 is 15. 28 minus 15 is 13. And then Q3 38 plus 1.5 times 10. So that 15 again. That 53. So we have 53 is the lower fence, and 53 is the upper fence, 13 is the lower fence. And we look at the data, everything is between 13 and 53, right? So the fences is 13 to 53, and all the data are inside that. So in this case, we said no outliers. So interquartile range, once again, Q1 minus 1.5 IQR, and then Q3 plus 1.5 IQR. Those are the fences. And on to the next section. We have file number summary and the box plot. So first, the file number summary, that will be easy. The minimum, the maximum, Q1, M, and Q2. Actually, on the calculator, let's see, do we still have any list? Right. If we just random find the mean, which is Q2, and then the mean of the first half and the mean of the second half, that will be Q1, Q3, right? That's simple. Now, what if we enter all the numbers here? Right, so I have all of that. And then quick second mode. If we do one variable statistic on that and go down to the bottom, these are the file number summary. Right, let's do that by hand. I will put them in increasing order. $6.5, next 9.9. I wrap the percent because just have more, take more space. 12. No more 12. 13. 13.3. 13.9. Now the 14, 14.3, 14.4, 14.4, and 14.5. Obviously, that's the minimum, the maximum. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in the middle will be right here, 5 above and 5 below. And so there's nothing in the middle. We have to take the average. 13.9 plus 13.3. Divided by 2. 13.6. So that is M. And then we have the upper half and the lower half. For the upper half, there are 5 of them. so the one in the middle, so that 2 above and 2 below, so that is Q3, and then Q1 is 12. So the 5 number summary the mean 6.5, first quartile 12, the median 14.4, the third quartile, and the maximum. Right, so again, the calculator can give you that information as well. At the bottom, yeah, 5 number summary. Right, next, construct the box plot. Now this, if we just plot the box plot, that will be easy, but now we do with every bell and whistle. That's a little bit tedious, so pay attention. So first we find the lower fence and upper fence, so that's easy. After we have the IQR, now we draw a line number long enough to include the maximum and the minimum values. Insert the vertical line at quarter Q1, M and Q3, and close this vertical line in the box, so that we have the box. And then the other book to use the box and whisker graph, so there's the box, and then we have the whisker or the line below the label the lower fence and upper fence, and after that draw a line from Q1 to the smallest values within the fence, and then within Q3 to the upper fence, and then the whisker, they're called the whisker, and then anything outside that is outliners. Right, so from the previous example, we have those 5 number summary, right? So again, 5 number summary from the previous example. Right, 6.5, 12, 13.6, 14.4, and 14.5. Those 5 number summary. Right, and then we calculate the fences and determine if there's any outliers. Right, in order to do that, we have to find the fences. So the IQR, so Q1 and Q3, I'll calculate the IQR. Q3 minus Q1, uh, 14.4 minus 12, that's 2.4. Right, next, the fences. The lower fence will be lower than Q1, 1.5 times IQR. So the Q1 is 12, so it will be 1.5 times 2.4. 12 minus 1.5 times 2.4. So that is the lower fence of 8.4. Now the upper fence will be equal from Q3 and 1.5 times that. Q3 is what? 14.4 plus 1.5 times 2.4. Is 18. Right, so now we're going to plot. Obviously we have to plot anything that includes all the fences, the smallest number and the biggest number. So when we look at all of this, of course IQR doesn't count. That is the smallest one and that is the biggest one, so we have to draw a number line that includes those numbers. So we have to be the lowest one, let's say 6, and the biggest one 20. That's about right. Yeah, so we go from 6 and then 20. Right, let's do 6 and 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Right, so that covers everything. Right, now first we wrote the three numbers in the middle: 12, 13.6 and 14.4. 12, draw the vertical line there for 12. 13.6, 13.5, a little more, 13.6, and 14.4, which is 14.5, a little less. So we draw the box. So this is Q1, 12, Q1, 13.6, that's the median, and 14.4, that's the Q3. So that's the box. Now the whisker. Before that, let's label the fences: 8.4, 8.5 here, so 8.4 a little bit on the left, and then 18. So that's the lower fence and upper fence. Now it says that whatever we draw will be from the Q1 to the smallest number within the fences. Of course, we're not going to draw on the 6.5. 6.5 is out here. The next one is 12. Oh, I have to look at the data. Okay. So we start from the quartile all the way to the numbers that is still within the data and not within the fences. So I have to draw that up to 9.9. Stop at 9.9. And there's an outlier 6.5. Yeah, so outlier we draw the asterisk like that. And then we draw that up to the biggest number that's still within the fences. So 14.5 still within the fences. Yeah, that will be that number. So from the first quartile, we draw up to the smallest number within the fence, and from the third quarter going up to the biggest number still within the fence. Anything outside of that are outliers given by the asterisk like that. Right. Next example, construct a box plot for this, the grade for 10 students. Right. Just make things interesting. Just 10 that to 11. So that guarantee to have, so that we have a chance to have an outliers. So see how we plot this thing. Right, there are 10 students, right? So the median will be in the middle here. So that we have 5 number on the left and 5 number on the right. So that is the median. Between these two will be 81. Next. Within the lower half, there are 5 of them. So this will be Q1 and Q3. Yeah, so 2 above, 2 below. Right, so we have that 5 number summary. Actually, I think 51 will work just fine. Just give it. Right, now IQR Q3 minus Q1 84 minus 76, that is 8. And 8, and then sorry, I don't know why I need to do that. I don't know why I need to calculate for that. Right, low fence is subtract from Q1 1.5 times IQR. Q1 is 76, and we have 1.5 times 8. That will be 12, 76. $64. Upper fence Q3 plus 1.5 of IQR. 84 plus 1.5 times 8. It's 96. Good. Right, now put everything in here. So first we have the number line that enough to cover everything, including 96, 64, 51, and 99. So have to cover everything. So let's go from 50 to 90, 100 then. 50 to 100. $50, 60, 70, 80, 90, 100. Right. Good enough. Now, first we roll the median and the 2 quartile. 81 is the median. $76, $75, $76, and $84. So 84 for the 3rd quartile and 76 for the lower 1st quartile. The fences at 64, 65, 64, a little bit on the left. The lower fence, the high fence is 96, 95, 6, a little more than that. So because of course we can label them. This is lower fence, upper fence, median, 3rd quartile, 1st quartile. Right, now we are standing from first quartile down to the numbers still within the fences. So from 76 we'll go down to 70 and we stop at 70. We're not going to go to 51 because 51 is the outliers. And then from the third quartile we go up to a number still within the fences, 99 outside the fence. So we go on to 90. And then 99 is an outlier. Right. So that is called the box plot or the box and whisker plot. Anyway, so with that, we finish chapter 3. Thank you for watching and see you in another video in statistics.